No. So welcome everybody to the day 2 of the NF Core Hackathon. Today we'll have a session talking about DSL2 and modules in Nextflow. And we have first a talk by Evan Floden and Paolo Di Tommaso, who need no introduction. So yeah, I'm gonna give the stage directly to Evan, and he's gonna talk to us about DSL2 for NF Core.
Awesome, thanks a lot. Yeah, it's super exciting to talk to everyone here today. Maybe I'll do a small introduction, maybe. So I'm Evan, I'm CEO and co-founder of Sekira Labs. I work with Nextflow. We've also got Paolo on the line. If you don't know Paolo, is the main developer of Nextflow. And as I said, we wanted to just, we're asked to do a very small introduction onto DSL2. So if you don't know, DSL2 stands for Domain Specific Language 2, and it's an extension of the Nextflow language. And the super exciting thing is we've been working on this now for, I think, almost a couple of years. And in the next week or so as part of the July release, this will be being rolled into the kind of main release of Nextflow, and then it'll start to become more widely used. As I kind of prefix this, I've been using it now for probably almost a year now in terms of the main pipelines I've been developing, and I've found it phenomenally powerful, exceptionally useful, and once you get your mind into using this way, it's typically the way to go. At the same time, we still sort of teaching it from the basics of how to use the traditional Nextflow, because I think it's important to get the kind of concepts right to begin with. But to begin with, what I wanted to go through was just to imagine our existing pipeline. And if we think about what the data pipeline's got, you can kind of split it into two parts. So you can think that there is the part where each process or each task is trying to trying to run some piece of software, run some script, do some processing of some data. And then there's the second part you have to think about, which is how you connect these things up. So traditionally, it kind of looks kind of basic, like in this example, but as we say, we've seen many times before that if you have very complex examples here, this becomes quite difficult. And what we're sort of thinking about with DSL2 is how you can split these two things up. And in splitting these two things up, it actually helps you write more efficient pipelines or write pipelines more efficiently. So the two parts that I'm talking about here are essentially where you write your code. This is the process block. This is where you focus on the actual task that you need to write, that the pipeline should run in that moment. And then the second part is much more related to what the inputs and outputs of those are, what the channels are, the data flow programming side that we see here. And that is the separation of these two things is one of the main aspects of DSL2, along with several other new additions, which can kind of result from that change that we're able to do. So as we've been working on this for a long time, so it was really one of the more requested features over the years was to be able to add this to Nextflow, be able to modularize the workflow definition, to be able to create independent components, and then to be able to reuse those independent components in different workflow projects. So essentially the reuse of components was an exceptionally important part, and being able to do that into Nextflow. It also allows us to break up the script. So you think that typical Nextflow pipelines are one massive .nf file. And if we're able to break that up, we can kind of split the monolithic script up and use it into both reusable pieces, but also more manageable aspects of it. The challenging thing about this is that in Nextflow, the processes had the kind of implicitly defined what the inputs and the outputs were. So the execution of the pipeline using these processes was kind of intrinsically linked into what the pipeline was doing. So if we look at, say, so for example here, this is the typical example that we use, but consider the process here. Notice that the process contains the channels in here. So it contains from genome channel, from reads channel. And because these are declared implicitly, they're really also defining the dependencies associated with that task, or with that, the dependencies associated with that process. So because the process definition implicitly determines how the process will connect to the rest of the workflow, it makes it difficult to split up, because this reads channel, for example, could be used in another step, and then I can't, for example, define the align sample and the downstream process. Because consider that when we show here, now these two processes are linked together. So therefore, it makes it very difficult for me to take index sample and use it in a different location. So as I said, DSL2 is a major revision of this. It's really focused on the modularization, fluent definition, component reuse. And we've been working, say, for quite a long time to be able to do this. And it's very, it's kind of great to finally see that over that time, the iterations that have gone on, the time that we've spent working with the community to work on specific aspects of it to define it, really paid off into making something which is now ready for the stable release. Okay, so if you've ever used Nextflow before, you shouldn't find DSL2 to be too different. It's really a natural extension of what we've got. To keep backwards compatibility, we've added this definition at the start of the script that you use. So if you enable DSL2 like this, then you're able to use DSL2 in your script. The key thing to note when you look at a DSL2 process is that now we're no longer defining what the channel inputs are. So the process doesn't need to declare from and into for that component. And previously we were using from to say where the process was receiving the data. We were using output to say where the data was going to, but we no longer need this anymore. So we just have this original path transcriptome and path index. This should be fairly standard. So the thing that comes about is now the process definition is no longer tied to a specific channel or data flow. And therefore we can use it independently. So how do we use these independently? How can we take these DSL2 components and then reuse them in a pipeline? Well, this, for example, this index process could be defined in another file, and we can include it into a main script. Look at this example here. This is a DSL2 workflow definition. We are including the index, including the index process from some file, some module that we could have defined. It could contain one or many of these. And then on the workflow step here, we could say we want to define exactly like you would in Nextflow. So we have a new workflow definition here, but the transcriptome is the same. So this is just defining a variable here, the params.transcriptome. This is all standard Nextflow. Read pairs channel from some file pairs. And the difference now is that we call the processes almost as functions. So instead of having to include the process block here, where you'd have a block of the process, we can just name the process, and the inputs themselves are in an order that they would be expected by in the process. So transcriptome becomes the first input channel to index. Read pairs channel becomes the first input channel to FastQC, and the quant process has two input channels. The first one is the index.out, so the output channel of index process, and the second input is the read pairs channel. Another thing to note here is that with DSL2, we're able to reuse channels several times. So we no longer have this limitation of having to split the channels out. I can use read pairs channel here, and I can use read pairs channel here without having to split it. The other thing to note is the use of this .out. So with this .out, I'm able to access the output channel of index without having to necessarily define it as a variable. And this can have some advantages for just making it simple to see. Okay. We also have a new way of actually defining workflows or sub-workflows in this case. So we can provide a name. We can just see, for example, workflow RNA-seq. And then we can have these new words for defining what the inputs and the outputs, not only for a process is, but what a workflow is. So we use take, which is the word for the kind of input of a workflow. So we have the transcriptome, read pairs channel, as we had before. We can then have the main section, which is what is executed. So index, fastqc, and quant, exactly the same as before. And then the output of the sub workflow can then be defined with this emit keyword here. So this is a quant.out. Final thing I'll show you, and then I'm going to pass you on to Paolo, who will do a full demo of how we can convert a pipeline to DSL2. We also have the ability to use pipes here. And what this is saying is that we can define, we can write our workflow now no longer sort of all on one line. We can pipe the outputs of processes, of operators to the input of the next step. So imagine this example here. I'm looking now in the workflow block. So the channel.fromPath params in. This is creating a channel, which is containing our input. I'm going to pipe that channel to split faster, which is a next flow operator, which is going to split the faster up. The output of that operation will then be piped to the align process. So that align process will run for each element, which is emitted from that channel. And then finally, I can pipe it to the view operator to view the output of that. So this is a kind of a neat syntax that we can have to really powerfully use the concept of Linux pipes and really use the expressiveness that comes about from using Linux and apply it to now distributed computation with Nextflow. So with that, I'll pass you over to Paolo, who will do a more of a demo and hands-on into how we can use this and the basic concepts behind it.
Nice. Let me share the screen. Okay. Yes, the idea is that to show you how to migrate a small pipeline, a small or a big pipeline to this new syntax. I'm going to use our small RNA-seq pipeline that we've used for demoing purpose. That is this repository Nextflow.io RNA-seq. I have a local copy. And I think most of you already seen this, but if you have never seen, there are just small for task. And there is at the beginning some parameter definition for the read, transcript tone, the output dir, etc. Then just a log info that shows some runtime information, some information about the input, the pipeline. Then there is the read pairs channel definition with the usual trick to split the channel for the limitation on Nextflow to manage multiple inputs. The same channel has multiple inputs. And then there is a task for the index creation using Salmon, then the quantification step always using Salmon, the fastqc step, and then finally multi-QC that collects all the outputs and create the final report. So the first thing to enable DSL2 syntax is to declare this flag at the beginning to make it possible to allow Nextflow to use both syntaxes without breaking existing code. So this is an opt-in feature that must be enabled using this flag. The final version preview will be replaced with enable, but for now we can just use preview. And this is enough to tell Nextflow that you want to use this new syntax. So like Evan was mentioning, it's not a radical new syntax for Nextflow, but there are a few changes that allow us to make many more things. And the first thing was to remove all the from declaration from the processes, because this will allow us to reuse this process definition in multiple places, like an independent module. So we have just to remove all the from part. And this basically make it possible to use now the processes like the definition, the task that I want to execute, but without linking them each other. So they are independent modules, basically. And the same way, I need to remove the into definition, including this. This was, I will enter more in detail about into later about this part, but we have to remove also this, then all the process into definition. Here, okay, we are done. So now we have the task, but if I try to run this, it's doing nothing, because what is happening now? Because I don't have any more. Okay, it's telling that there is a report, but actually it's down everything. Because I have just a task definition, but there is no declaration how we want to use there. Because before we have the definition, the from into that was creating the relationship between the tasks. Now this does not exist anymore, but we can use, let's remove this because we don't need for now. We have the ability to declare a new component that is workflow, that is what allow us to recombine all these tasks together. And for example, I want to start using the index like before. Now, since I declared in the index task one input, what I have to do is to use the process index passing the input that I declared in the process definition. So here I know that I can pass the parameter transcript tone. So basically the process becomes like custom function that I can invoke inside the workflow scope. This is what DSL2 allows you to do, to reuse the processes like function, custom function that run your task. It is enough to run this workflow. Running, let's use Docker. I also resume, no, without a resume. This will run the first task. And now, basically what I have to do is to recreate the pipeline, recombining the task like before. So I index, then I can use the fastqc task. The fastqc was declaring the read pairs. And this is what I was doing here in the channel declaration with into. There isn't any more in DSL2 the into operator, but I can use just this channel. Another advantage of DSL2 is not just about modularization tasks, but also it removes the need to split the channel when I have to reuse in multiple places. So make the syntax much more readable with less declaration, the same different channel name for the same channel. So much more concise. I can use read pairs here, and now I can run it again. Okay, now I have execute two tasks. I'm still executing it. And then I have the quantification task. Quantification task is taking the index generated by the previous index task and then the read pairs. So how now I can combine these two things? I can express in different way, but the simplest way that you can use is to use the process name to reference the output that it produced. So here I can say that index, I want to take the output index using this implicit variable that we can apply in the index task. So I'm telling invoke the quantification passing like first argument, the output of the index invocation. And since it's taking a second parameter that is the read pairs, I can just use the same read pairs channel. So we can, here, this line, we are seeing two powerful features DSL2. The way to reference the output of a process, just say process name dot out, and then reusing the same channel 2 more times without having to split the channel like we had to do before with the into. So it's much easier, much more readable. Let's do resume now. Here it is. And finally, we have the multi-QC task. The multi-QC was a bit more complicated because it's taking the first parameter that was receiving all the output from the FastQC and quantification task, and we can do the same thing that we were doing before by using the new syntax. The new syntax would be that I want to take FastQC output, mix like before to what? To the quantification task out, and collect. This was the same snippet that I had in the previous implementation, but just adapted to the ability that I have now to use the process name to access to the output of that process name. But then I continue to use the same operator mix, the same operator collect, etc. And the second one was just the parameter multi-QC, I think, no? Let's try to resume. Fantastic. So these few lines show one of the main feature of DSL2, the ability to use process like custom function, how we can reuse the same channel multiple times, and how we can access to the output of process using this notation. In this way, we can isolate the main logic of the pipeline in a much more concise way, allow us to read this piece without having to recreate mentally the link between all the processes. So much easier to read, especially when you have a complex logic in your pipeline. But still, we haven't seen how to create separate models because I just readapted this pipeline to use the new syntax, but still I use it just a single file. So all the point was to create models. How to create models? I can just take all the processes and include it in a separate files. RNA tasks. Enough. Oops, there is too many R's. And that is Nextflow module is just an extra script that contains processes declared using the new syntax. So without into and from. Now, since here I'm declaring some parameter, I have to declare, like I will do in any other Nextflow script, these parameters with a default value result, so nothing changed. This is the usual thing. But now I can include this RNA task script from the main pipeline. How? Using include and then specifying the name of the processes that I want to include. So index, FastQC, quantification, and multi-QC. Why is not taking the other complete? Then I need to specify which is the script part, that is RNA tasks. The extension is not needed. Instead, the / is mandatory, and you have to specify or a relative path like this or an absolute path starting this way. And also there were some versions in which this was allowed, meaning include everything, but we decided to remove because that was easy to allow to include everything, but made very difficult to understand when you have many inclusion from where the processes are coming from. Also, the curly bracket notation was optional, but the final version, this is going to be the only way to define the inclusion, even if you have just a single inclusion like this, to make the syntax a bit more consistent, to have different way to include things with curly brackets, without curly brackets. So the inclusion is always with curly brackets like this. Okay, and this is enough to run it again. And fantastic, now I have the same pipeline in which the main body of the pipeline are just 50 lines. It is this, include the task. Then there is a channel declaration that I could even put inside here. And then the workflow body. And the nice part is this, that I can use this task in here as a separate module that I can include into different scripts. And also a nice thing that I can create modules, components that are not just single tasks like this, but also sub workflows. How to do? Well, just using this notation. Maybe I want to create a sub workflow that does always the index, the FastQC, the quantification execution. What I have to do into this file on a separate file, does not matter, it just declare a workflow to which I can give a name. Maybe RNSX pipe. I want to do, instead of invoking FastQC, I want to just have this like a piece, a component that they can reuse. And the problem is now how to isolate the parameter and the output. This can become input of the subworkflow using this take keyword that is the equivalent for the input that we are declaring in the process. In the workflow, instead is take, and allows you to declare an identifier that you will use like the input for the index, and also another input is the read period channel. Then start the body of the pipeline, and then maybe you want to return this output from the pipeline execution. And to declare the output in the pipeline, you can use emit. So what I have done, we are creating a sub workflow that takes this to the input, run these three tasks, and then we produce, like before, the combination, the FastQC output and the quantification step output. Let's try in action. I can include now the RNSX pipeline from this file. This confused me a bit here. I will put here. And then, so now instead of calling this, I can call RNSX pipe, passing params return and repair ch like before. And now multi-QC takes what? Takes RNSX out, and then like before, the parameters a parameter file from multi-QC. This is enough. So we can isolate piece of workflow in this way. Let's try to run it. There it is. now execute it from scratch because the namespace of the execution is changed. If you notice now, this process become RNA-seq pipe index, RNA-seq pipe fastqc, etc. And then the last one is multi-QC. So basically they are nested inside a namespace. And what else? The last thing that is nice to mention was already mentioned by Evan, maybe a couple of minutes about this, is this pipe notation that we have. The pipe notation allows you to concatenate operator processes together in a bit more readable way that it can be maybe more intuitive, especially since we are used to work with the Bash syntax and Linux syntax. It's just a way to combining the operator using the pipe notation also into an extra script. So basically, I could say that the fastqc out is piped to the mix operator. Since the mix operator was taking also an argument, we continue to use the parenthesis notation here, but then the output, the mix goes into collect. I don't need any more the empty, the parenthesis when there is no argument. And now, it's a bit more readable because we are saying that the workflow is producing this output, that is fastqc output mixed with the quantification output, and that collect everything. The only suggestion is try to not abuse to use this notation. I have seen some people trying to write 20 lines or script you concatenating all tasks together. Maybe that would make too complicated to read. But having small one-liner, I think is nice to make the code more readable. The last thing, the workflow can produce one output or more output, and you can give also a name to this, assigning them to a variable. So if I do something like that, then I will be able to access the RNA-seq pipe output using this notation. So the name that I use here into the emit section. But also I could say that I want to return what? The quantification result using quantification out, and maybe the fastqc result assigning to the fastqc out. So now basically my component, my sub-workflow RNA-seq pipe produce 3 output, and then I can choose which one I want to use, or all together, or maybe just fastqc result. Okay, these are the main feature on Nextflow DSL2, and the ability to create separate modules, library, or task and processes itself workflow that can be included each other, but also the ability to use this pipe notation, and also the ability to reuse the same channel in different places without having to use the into operator to create copy, make the resulting script much more readable, much more concise. And I think this is also why at some point we decided to call this DSL2, because it is a little change in the syntax, but at the same time, the impact that provides is so big that it's going to provide a complete new experience when write pipeline with Nextflow. Okay, this concludes my demo. I don't know if we have time for a question in the chat or whatever. Thank you.
Thank you very much, Paolo, for this hands-on demonstration. This will really help us port all our workflows to DSL2. And thank you, Evan, also for the introduction. And yeah, we do have some time for questions now, and we actually already have some questions in the chat.
Fantastic. Let me open the chat.
Yeah, I can read them out loud as well for the YouTube followers. So we have a question from Moritz. Since workflows can now reside in a separate module, it is kind of natural to start versioning them in separate repositories. Can we import from a repository URL?
Okay, yes, this is a classic question. The short answer is no, because at least not in the basic form that you can specify from a URL, because that is very dangerous for the stability of the pipeline. This was one of the biggest failure, I think, first generation of workflow engine that was allowed to import data or script from a remote repository. We know that this repository change over time, so that will make the pipeline super fragile as soon as this URL breaks. The idea is to instead to include external dependencies from, for example, using Git subproject or Git modules, and also another possible extension which the NF Core is working very hardly is to create a way to create a NF Core modules that will be possible to resolve use the NF Core tools. Maybe Phil more details about this.
Yes, exactly. This talk will be followed by a talk by Phil, and he will explain more details about this.
Exactly, but not directly using a level Nextflow language.
Exactly, yeah. So we have another question. I like the pipe feature. Will it be possible to pipe like in Bash, see the final output row by row, or does each process need to finish before the next one starts?
Not sure to understand well the question.
I think the question goes down to it. It's actually operating exactly like Nextflow. So when there is a process which has, for example, 100 tasks, it's actually operating in the exact same way as Nextflow running the thing. So it's happening in parallel, and it doesn't have to wait for one of them to finish. It doesn't have to wait for one process to finish before the next one begins. So it's the full workflow definition exactly like you have.
Okay, perfect. I hope that this answers the question. Does somebody else have some other questions? Please write them to the chat. So from Steve, the new DSL2 and module system resembles some aspects of CWL workflows. Do you think we might be able to use CWL tool definitions at some point using this?
In principle, it is possible. We had also a tentative to implement a CWL importing to run into Nextflow DSL2 CWL task, but we didn't have enough time to go into a real implementation. So there is a kind of proof of principle of this approach that show that it's possible, but it's nothing usable at this point. Maybe at some point we will implement this.
Perfect, thank you. Some further questions? So even if you have some further questions later, so at the end of all the talks, we will have a discussion session, so you can also continue asking your questions there. And we will continue now with a talk by Philip Ewells from NF Core, and he will introduce how do we plan to use right now DSL2, Nextflow DSL2 in NF Core organization. So stage is yours, Phil.
Thank you very much. Thank you for the introduction, and thanks for the excellent overview, Evan and Paolo. It's really nice to see you guys. I've seen that talk a few times now, but it gets more polished every time. So it's good to see kind of the features becoming more and more stable. It's great. So this talk was originally scheduled to be Harshal, and so he's put the slides together originally, and then we've kind of both been working on it. And he asked if I could give a talk, but it's going to be a bit more kind of hopefully a bit more interactive than some of the earlier talks in the week. So please jump in with questions as soon as you have them. Maybe Yosela will like interrupt me if there's any good ones, and I'm going to try and pull Harshal in for a bit of help every now and then. We'll see how we go. But I'll start with a quick kind of introduction to what we've done so far and kind of what the current state of play is for NF Core modules. So let's see if I can share my screen, and we'll get cracking. Okay. So yeah, so like I say, most of these slides were made by Harshal originally, and then I've kind of tacked my name on at the end, but really well by him. So a little bit of history. I think I first heard about DSL2 in November 2018 at the Nextflow kind of meetup, which was made to great fanfare and a lot of excitement. One of the main arguments against using Nextflow from other communities was the lack of this kind of feature. So it's kind of been highly anticipated for a long time. And when Paolo announced it, it was really, really well met. So that was a talk by Paolo and a kind of a demo. And then there was a blog post in May of last year by Paolo kind of explaining the main features and giving some code snippets and explaining how this was going to work. We, of course, were discussing this within the NF Core community, like from day one, about how we were going to work with this, what we should do, what we should aim to do, and kind of what kind of features we can build around this new syntax. And the obvious route to go was to try and create a central repository of software tool wrappers, which could be shared across different NF Core pipelines or any Nextflow pipelines, to try and maximize code reuse. And so in July of last year, we started a new repository called NF Core Modules to try and kind of spearhead this. There was very little code added to that pipeline, to that repository for quite a long time. There are several GitHub issues created though to discuss approaches within the community, and both there and on Slack, there's been the highlight so far of this effort has been a massive amount of discussion. Because once you start to really get into the details of how to implement this thing at scale across large numbers of developers in a very stable, reproducible way, there's a lot to consider, and it gets very complicated very quickly. So there's lots of discussion, and then we had a hackathon earlier this year in London at the Crick, organised by Harshal. And that was really one of the first times. There'd been some kind of little efforts at some of the earlier hackathons, like at SciLife Lab, but really the one in London was the first time we made significant impact and actually started writing real code. Where a lot of people started writing different wrappers for new tools, so we actually had more than just FastQC in the modules repository. Started a repository to kind of play around with a DSL2 pipeline, which we called DSL2 pipeline test, and kind of tried to work out how this would work in reality. And we also started, well, I started building mostly some new continuous integration GitHub Actions kind of automation to try and help some of this. And missing from here is that we also started building some of the NF Core tools software, so the helper tools. We started adding some new features into that, which would also help developers work with this new system. That kind of trundled on for a bit, had a bit of a quiet period, and then a couple of weeks ago, we sort of thought maybe we should try and get this in shape before this hackathon so we could work on it. And so the last 2 weeks have been pretty frantic activity on the NF Core modules. Harshal's done a lot of work along with other members of the core team, especially, to start work on converting the current NF Core template, which is like our kind of central golden kind of reference point, converting that from DSL1 to DSL2. And that work is ongoing on a branch on the NF Core tools repository. Going really well. Okay, so that's kind of how we got here. I'm now going to go into a few of the discussions that we've had to talk about the approaches we've decided to take and why that is.
Hi,
Now,
Phil. So we do have a question from the audience already that is fitting to this slide. So we have had already a lot of developments in DSL2. And a question is the DSL2 syntax considered stable enough right now to start using it in production?
excellent question. So we've had kind of competing pressures for modules in DSL2 since it was announced with Nextflow. Of course, we want to stay relevant. We want to move quickly enough that we are not left behind by other people, and that people who want to use DSL2 won't kind of give up on NF Core. And we also, of course, want to use all of the powerful features that come with NF Core. However, as you quite rightly pointed out, DSL2 has not been considered stable yet. And NF Core pipelines, the first thing I say in every introduction talk is that they are portable and reproducible. So stability is critical before we actually push anything into production here. So there's a kind
quick
of
information
balance there. Paolo, come on.
Yeah, quick information. Yeah, we are going to release next week.
There you go.
So we are there.
You heard it from the man himself.
Oh.
So exactly. So as of next week, there'll be a stable release of Nextflow. We're going to hold Paolo to that. And then after that's there, then we can start using DSL2 for real. So we're nearly there. Any more questions before I move on? Cool. So this is partly the work of this week, actually. There's been a lot of discussion on Slack for those who've been kind of following it. And it's also covered in one of these issues on the NF Core modules repository. We've started tying down some of the best practices that we're going to ask people to adhere to when writing process definition, process wrappers. So, right, Harsh will butt in here if I get any of this wrong. Module file should only define inputs and outputs. I don't completely remember what that means. Can you help me out?
We initially, I think, are going to try and keep the process definitions as simple as possible in terms of providing parameters. And so ideally, we'll try and follow the Nextflow model, which is what I've envisaged. This is still sort of up for discussion, but I think we're going with a simple approach. So Nextflow, by definition, requires inputs and outputs, sometimes not inputs and sometimes not outputs, but I think you get the drift. And so what we're going to do is we're just going to, for any tool, for example, FastQC, you'd only be providing FastQ files to FastQC, and you'd be taking zip files or HTML files as output. We won't be providing any other parameters within the process definition. And the main reason for that is that if we want these wrappers to be flexible and for other people to be able to reuse them, they should be able to provide their own parameters when they're running these module files. And this at the moment seems to be the most flexible way of doing that. And so the other point on that slide, which says that all the other parameters can be provided by a parameter string, which can then be used by the tool. So this is kind of what we're thinking at the moment in order to take this a bit forward. Also, so threads and other stuff, which you can use standard Nextflow variables like task.cpus. If the tool supports multi-threading, then you can provide that as a parameter for the tool, because it just makes it easier than having to do that, and it's quite standard anyway. But yeah, all other parameters ideally should come into the module via a string of some sort.
Cool, thanks. So yeah, I guess my way of rephrasing that would be, we don't have hard code specific options for any tool other than the mandatory arguments. And everything else which is optional, so yeah, FastQC options or trimming distances or adapters or anything like that should be put into that single parameter, which will be just a generic string. Then of course the pipeline, which uses the module, then that pipeline can have whatever parameters it wants. So it can still have all the same customization that we currently have with NF Core pipelines. It's just that the module wrapper itself should be kept minimal. And yeah, stuff like task.cpus, because that's hard-coded from Nextflow, that's always available. Apart from when it's not. But then we can check for that in the code. Okay, and then the final one is a simple one, that we should call our processes by a name, which should be all uppercase. This is purely aesthetic. It just helps when you're reading a pipeline, it just makes it a bit easier to kind of know what's a process and what's a Nextflow function. etc., or a variable. So that's purely stylistic, but just makes life a little bit easier to read. Okay, so extra stuff that should be in that process. Currently, for those of you who have dug around within NF core pipelines, you'll have seen that we have one process which calls every single tool used in the pipeline with a version command and writes all of these to one file. That multiple files, but those files are then used to kind of grab the versions from the software and put them into multi-QC report for reporting at the end of the pipeline. Now we are kind of, instead of having all of those version commands within a single process, we're asking that each process does the version call itself into a file. And we'd also like to use some bash regexes to clean those version strings up as much as possible. So we have a minimal file with just a version number for that tool. And then we'll collect those outputs and again, still report on them in the same way. It's just that that part of the version reporting is delegated within the process actually doing the job. Modules should be minimal. So this is kind of simple. We just, don't try to chain too many things together within a single module. It's fine to have lots of modules which chain together, but each module should be absolutely minimal where possible. Ideally, that means a single tool doing a single thing. The exception is when we need Unix pipes for really heavy lifting. For example, using SAM tools here to convert SAM to CRAM or to BAM, where it's just kind of a bit unrealistic, or there's a large time penalty for creating intermediate files. So it should be minimal with some exceptions. This helps with a lot of stuff. It helps with simplicity of the code. It helps with maintenance, and it also helps with software packaging inside the Docker containers. Okay, last one is a bit of a, just mentioned because it's a shift from what we're currently doing within NF core. So most NF core pipelines that work with genomics data, there is a params.single end. So if you want to use single end data, you do -- single end, and that applies to the entire workflow run. We want to shift this partly so that we don't have to handle parameters everywhere. So now we still want to have an explicit variable defining whether the data should be treated as single end or paired end, but that should be passed in a channel as a value with the input channel alongside each set of data. This has some really big advantages. For example, you will now be able to mix paired end and single end processing within a single workflow run, and will also tie into sort of more fine-grained inputs in the future. It is possible to infer whether data is single end or not by looking at the input channel. For example, looking at how many different files are supplied, whether it's one or whether it's two. But although this is possible, I would advise from years of experience that typos are easy to make within glob expressions, and other things are quite easy to accidentally run paired end data as single end. We used to do this years and years ago, and we opted for that explicit param instead because it just saved us from a lot of pain. So we're going to stick with that. We're going to say no inference of single end. It must be an explicit variable, but it should be passed in with the input channel.
Thanks, Phil. So we have a question about this slide in the audience. So what about multiple processes in one module? For example, should it be one module per SAM tool, subcommand, or all subcommand in the same module?
Yeah, I'll show you. Do a live demo at the end of this, and we can have a look at what modules are there already. It should be one module per subcommand. So SAM tools has multiple sub kind of folders, there's one for view, there's one for index, and so on and so on, to keep them minimal. So we can organize the directory structure so that there's just SAM tools and then we have all the subfolders there. That's no problem, so that we keep things organized. Does that answer the question?
I hope that answers the question, Maxim. Otherwise, just ask again. And we also have a question from Steve. Are there any guidelines about usages of custom scripts inside modules?
Good question. I don't think we have any guidelines on this yet. There definitely will be plenty of cases where we want custom scripts, and I don't see any problem with including them there at this point.
I think maybe so I have been thinking about this. So at the moment, because we're still trying to find our feet, I think we will reserve NF Core modules, or it makes sense to reserve NF Core modules just for existing software that's out there. And so at the moment, during this hackathon, actually, we're trying to re-implement the chipseed pipeline and SARIC actually in DSL2. And so part of that is also to identify, problems in porting to DSL2 and to actually write some of these guidelines as well. But at the moment, what I'm doing is in the pipeline repository, what I've put is a modules folder. And within that, I've got another subfolder called local and another one called NF Core. So all the stuff coming from NF Core modules will be in the NF Core folder. And anything that is more customized and things that I need to keep locally in order to get the pipeline running, I'll put in local. So it's probably best to keep them there for now until we find our feet with all of this. Is what I would probably suggest.
Yeah, that was something I meant to cover at in the introduction, and I completely forgot. Apologies for that. So the NF Core modules is for common tools which are possible for other people to use in other pipelines. We expect NF Core pipelines to have a mixture of processes from the centralized repository and also processes which are specific to just that pipeline, which are in this local folder. And of course, pipelines can carry on using scripts in the bin directory and everything as they do currently. So that's kind of expected to have a mixture of both of those. But yeah, I'm sure that in the future, we're going to come across really obvious use cases where we'll want custom scripts within NF Core modules, but we will have to figure out how to do that when we get there. we haven't encountered that yet. We don't have any guidelines for that yet. It'll be a learning experience. Your question also reminded me of another common question we get, so I'll just preempt that and answer it myself before anyone beats me to it. Sub-workflows that Paolo described. So with DSL2, we can have module wrappers around specific tools as processes, and we can also have these sub-workflows. And it's quite easy to foresee a future where it might make sense to kind of start to provide those in a central repository as well. We're aware of that and we're ignoring it for now. So again, that's another one of like, we'll tackle that when that becomes an issue where we really want to do it. I very much expect that to be something that happens, but we haven't really thought about it yet. I would very much recommend that pipelines themselves in the local pipeline do set up mini workflows. Very often, at the moment, NF Core pipelines are littered with -- skip this, -- skip that. The workflow scopes will make that much more elegant to use. If you want to use just salmon in the RNA-seq pipeline, you would be able to do workflow salmon. If you want to use HiSat, star, etc. So you can imagine having these sub-workflows within each pipeline working very elegantly, and then having the default workflow which chains those together. So sub-workflows, yes, definitely. In pipelines, certainly. And probably in the future in modules, but we don't know how yet. Any more questions? Right, I'll crack on. Oops. Software dependencies. This is something where those of you who have followed the discussion in NF Core about modules might be a bit confused to see what's on this slide because we've changed our minds a few times. Currently, NF Core pipelines, we recommend that a pipeline has a single environment file with all of the different software requirements and a single Docker wrapper where possible. This was an early decision, and the main reason was that a lot of people were using NF Core pipelines, especially at the start, were using Singularity. And basically, if a pipeline had kind of 20 different containers, you had to have 20 different Singularity images, and the file size started to get quite large. However, that in some cases causes issues. It means it's more difficult to install software if they require different versions of Python, things like this. And so really as a developer especially, it's much easier to work with a single Docker file per process. With shared modules, which we're talking about here, this is just mandatory. There's no other way to do it. We have to have a single Docker file per process. So that kind of forces our hand. Initially, we thought about recommending that we use other publicly available Docker files. For example, biocontainers is a big one. Hopefully will be a talk by Björn about biocontainers later in the week. We're still thinking about that. But for now, because we still want support for Conda, we recommend that every process has its own environment file. which will hopefully be very small, just be the channel declaration and then maybe a single tool in there with a pinned version. And also a Docker file alongside that, which again looks like all the same NF core Docker files we have at the moment, which are very, very minimal. Just take the environment and build a Conda environment within a Docker image. And then we will build those Docker images ourselves and use them within the pipelines. It's still some outstanding questions about how we're actually going to do this, especially with versioning. If anyone has any bright ideas, I'd really like some ideas on how to solve the versioning issue with Docker files within the pipeline code. But this is how we're going to start off at least, and we will explore other approaches later on. But for now, this is the easiest and the most stable way to do it. We've used Docker Hub so far for everything within NF Core, but we're probably going to use GitHub Docker repository going forward with NF Core modules. It allows us to have multiple different images, Docker images within a single repository, which is really nice. The automation works well, and we're kind of centralizing everything into GitHub, which just simplifies much of the management. At the moment, for example, if you want a new pipeline, one of us in the admins has to go and create a Docker Hub repository for you. Whereas if we're using GitHub directly for everything, it's a bit more streamlined. Okay, so environment and Docker file probably went into too much detail there, sorry, but that's how we're expecting that to work. Yeah, explicitly pin the software versions in the Conda file. There's a lot of questions and a lot of discussion about how versioning of NF Core modules will work. So I'm going to talk about this more, I think, on the next slide, where we talk about how we're going to pull modules into the workflow. But effectively, what we want to have is on the NF Core modules repository, the shared repository, we'll try and track the latest versions of those tools. So if a release comes out that will be updated on the NF Core modules repository, a new Docker image will be built with a new version, and the new pipeline code will be automatically tested against it, and that will be committed as a new commit to the NF Core modules repo. If your pipeline needs a new version, you go to NF Core modules and you do it. You don't do it within your own pipeline. Then everyone benefits, and it also keeps this very strong link between modules and your pipeline. I'll talk a bit more in a second about the details of how that will work. Okay. We need to document what we're doing in NF Core modules so people know what's there and how to use it. This is slightly up for grabs, but the suggestion so far is that we write a YAML file, just a structured text file which sits with each module and kind of describes what the module does, what the inputs and outputs are, and who wrote it. We're not doing anything with this yet, but the intention is in the future that we can use this for automatic documentation, maybe some kind of validation and testing, things like that you can imagine. So we're kind of pretty much stolen much of the syntax from Conda YAML files here, and we just kind of set this out very early on as a template so that we collect this information from WordGo at least. GitHub Actions. So this is, we used to use Travis, now we're using GitHub Actions for everything for continuous integration testing. Just like all the NF Core pipelines, every module should have its own CI with a minimal test data set. This is one of the main reasons actually from the early stage why we wanted to use modules, is that we have kind of end-to-end testing of pipelines, but we really wanted module, like unit testing of the specific steps within a pipeline. So we actually run each individual step by itself and ideally actually check the outputs. Mostly at the moment, we just run a pipeline, make sure it doesn't crash, and then have to manually vet that the inputs and outputs look right before releases. But now we want to actually check and validate the file from each module as it runs. Unlike other pipelines where we have a test data sets repository, we've decided very recently that we think the test data should be on the modules repository. And ideally, if you just need some FASTQ files or something, you should share them between different modules so that we don't bloat it unnecessarily. Okay, so this is roughly what the NF Core modules repository looks like currently, the directory structure. We have the kind of basic stuff like the README and the GitHub workflows, and then we have a directory called software. This used to be called tools, and then Harshal pointed out that I keep calling everything tools in NF Core, and it was very confusing. So we renamed it to software. Within software, then we have the names of the main tools which we're supporting. So here we've got BWA, we've got FastQC, we've got SAM tools. And then you can see in some cases we have subdirectories nested under there, which is what I described earlier. So the different SAM tools commands, for example. And these can be nested arbitrarily. Then at the kind of the leaf folders, the end of those folders, we have what looks like kind of a mini Nextflow workflow almost. We have a main.nf file, which just contains that one process. We have the meta file, which describes everything going on there. And we have a test action.yaml file, which is used for CI. I'm not actually sure if that quite how that's used currently. I think that might be wrong. And there's also missing environment and Docker files here, but you get the general picture of it here. Each of those folders should also have a test directory, which will contain an actual Nextflow workflow, as well as all the input and output test data, which will be used to validate that unit. Right, importing. This is where I said I was going to come back to a bit more detail.
So Phil, now that you could go to the previous slide again. So we do have a question from Maxime, and it is, how can we specify the version of a given program within an NF core module?
I'm about to tell you. So versioning and importing are one and the same thing, basically, or at least they're very closely tied together. This is probably the single issue that's had the most discussion so far, but I'm pretty confident we're coming to a conclusion now. If you look at that issue thread there, it's very long. There's a lot of discussion there. And we've gone through a lot of different suggestions, and we've even tested out several of these. So if you go and look at that old DSL2 pipeline test repository, someone dug it out earlier. We actually deleted it from NF Core, but I forgot that I still had my personal fork floating around. It's outdated, don't look at it anymore. But in the early days, we tried using Git submodules. This makes quite a lot of sense. You just say, okay, we've got the modules repository. I just want to use that here, and then I'll be able to access any of those module wrappers. The downside are that when you clone the repository, you need to clone with submodules, git clone minus submodules, recursive initialization, which is kind of a hassle. It doesn't happen by default with Git, needs extra flags. It's just kind of liable to cause issues. The other problem is that then you can't have a submodule for parts of a repository, so you have to pull the entire NF Core modules repository, which could get very large and could be a bit problematic. The nail in the coffin for this one is that you can only import that repository once. And so that means you have the NF Core modules repository at a single commit across all of those different software wrappers, and they're all locked to the same version. That's important because you might want to have different versions of different tools running, and we'll do that by taking different versions of the NF Core modules repository. Hopefully that makes sense. Another suggestion was to have a library of modules. It's kind of very attractive given the possibilities here, and where we could host modules on an existing library infrastructure. The two that came up were NPM, Node Package Manager, and of course Conda, which a lot of people are very familiar with. We even got as far as making a Conda channel called NF Core, which is currently empty, kind of ready to have these tool wrappers. And we have a branch on tools which has a working implementation of using Conda. So basically, using Conda works. The downside of using Conda is that it's complex. It adds a lot of complexity into the automation and to the management of the modules. We started looking into how we could use bioconda utils to kind of manage some of this, and really it was going to turn into a kind of a massive job to really make sure all of this works. It's entirely possible we don't go down this road in the future if things start getting really big and unmanageable by ourselves. And it does have some advantages, but for now we've decided to kind of put that on the shelf and come back to it later if we need to. One of the main arguments for using Conda is dependency management. But it's an important concept here to remember is you're pulling in flat files from NF Core modules into your pipeline, and you pull those in chunks. So there should never really be cross dependencies, certainly as for someone for running your pipeline. The person running your pipeline just grabs that flat file repository and runs it all in one go. So dependency interconnectivity should be fairly complex, unless we start getting very complex with sub workflows. Okay, so what we ended up with was basically a homebrew solution using the NF Core Tools Python package. And on now merging to a dev branch, which will soon be released in version 1.10, is kind of a skeleton early version of a new suite of commands called NF Core Modules. And I'm going to just quickly demo that. So hopefully you can all see my prompt here. I'm just in an empty directory called demo. If I make a new pipeline with NF Core create, I can just call it demo pipeline. What this does is it takes the NF Core kind of template and just builds me a skeleton workflow to start from scratch. You can see it's made a folder here called NF Core demo. And if I look in here, I've got my main.nf and my Nextflow config and everything. This is a DSL1 pipeline, but currently got that work going on I described of converting as template to DSL2. So what I can do now is also start to play around with these. If I do NF Core -- help, you'll see I have a new command here, modules, which has not been there before. And if I do NF Core modules help, you'll see it comes with its own subcommands. And these three don't do anything yet. They'll just tell you it's not yet implemented, but these two do work to some degree. So as the two ones do, they fetch the available modules from the NF Core modules repository and list them. And this one installs one of those into your pipeline, which basically just means it copies the relevant files. So if I do NF Core modules list, we will hopefully get a nice list. There we go. With the different available tools. We've got Bowtie, we've got the SAM tools, different wrappers here, we've got FastQC and so on. I've got my pipeline here. Remember, if I do NF Core modules install, I give it my pipeline directory and I say I want to install FastQC. It will go off, it will check that it's a pipeline folder that I gave it. It will check that the FastQC exists in the NF Core modules repository. And if I go into here, I can do git status. And you can see I've got a new folder here, which has not been seen before. If I look in this folder, you can see it's copied all of the files for this wrapper. And so then I could use those within my pipeline. I just import from module software FastQC. This probably will need fiddling with a bit. I just realized that Harshal said he had these tools within an NF Core subfolder. So I need to add that. But you can see the concept here. This Python script is very simple. It's just looking what's available on the GitHub repository and then copying those files and avoiding the test folders and stuff like that. What will come in then is more validation to check that we'll make sure that when you push changes to your pipeline that you haven't changed these files at all. They should match exactly to NF Core modules. If you want to change something, you should do it on the NF Core modules repository. And also to like update them and make sure that they're locked against specific Git hashes of the NF Core modules repository. So eventually, coming back to your question, Maxime, about versioning tools. On NF Core modules, you'll have a history for each tool. So we'll start when it's first added, that will have its own version with a commit hash of the code and of a Docker image. And then each time it's updated, you'll have new commit hashes for that tool and new Docker images for that version. So we'd recommend always that you always just update all of your modules and just have them all at the latest commit of NF Core modules, which will then also have the latest versions of those software. But if for whatever reason you want to have a specific earlier version, you just pin that Git hash for that wrapper. And then you'll have that software version and that version of the tool. This also means that when you make your pipeline, you can be sure and confident that it stays stable. It doesn't matter if people start updating NF Core modules. Firstly, you've copied those files out of NF Core modules, so they're contained within your pipeline and stable. And secondly, they're tied to a specific hash of the NF Core modules repository. Okay, any questions before I move on? I've either put everyone to sleep or everyone's got a headache. Right, I'll move on. I think we're nearly at the end now. Yeah, okay, so this is the demo. Yeah, that is the end now, okay. Cool, right, Harshal, did I miss anything?
No, I think that's about where we are with DSL2 at the moment. if people do want to get involved, we're having a bit of a sprint at the moment, like I said, on Slack in the hackathon channel for DSL2. So get involved, and yeah, thank you for listening.
So thank you, everybody. So now we can have a discussion question. There were a couple of questions that I didn't ask yet because they were not directly related to the slides, but you have now the chance of asking them yourself to any of the speakers today. So raise your hand here in Zoom if you have some questions, please.
Do you think you could repeat the questions, Gonzalo, which are written in the chat? Because there's a couple sat there at the moment.
Yes, I can also repeat the questions. So a question to Paolo. Are there optional and/or named inputs for modularized processes, like for outputs with emit? Let's say I create a process for my tool, which has dozens of parameters, a lot of them optional. It could be nice if I could just call my, yeah, it's difficult to read because there's a bit of code in between the lines. So if that person could speak up themselves here or raise their hands, I can unmute them. They can probably ask themselves better.
Yes, this is an open problem. There are some ideas, but it's not going to be available in the upcoming release next week. But yes, this is something that need to be solved in the next row, to have a better handling for optional input output. So not next week, but hopefully soon.
Okay, perfect. I hope that this answers your questions. We had also another question before. I was wondering how difficult it would be to have multiple pipe connected script blocks per process task.
Yeah, I can go. I'll go on that one. So the idea would be, imagine that you had several processes that you wanted, or several process definitions that you wanted to run at once. So at the moment, each Nextflow task is submitted out to the infrastructure that you need to send it on. So for example, if you're going to send that out, it would each go onto a virtual machine on AWS Batch or a node in your cluster. Now, the idea would be that if you could link two of these files together, or two of these processes together automatically, you would no longer need to transfer the output files to the input of the next process. There's some ideas on doing this. In some ways, it would break, could potentially break the pipeline across different infrastructure, because if you were doing this, if that could only happen on some infrastructure, it may break some pipelines. So also other ways of having be able to, imagine being able to stream the data from one process to another. These are all open ideas as well, and things that we will be working on, because as the person who asked the question has said, this would make things much faster. You wouldn't have to have intermediate files. You wouldn't have to necessarily write to disk, and you could really speed up a lot of the execution time. So it's a very good point, but something that we'll be working on for the next little bit.
Okay, perfect. Thanks, Evan. We have another question from Rad. Any chance of using version tags as well as commit hashes for modules?
Yeah, I can take that. It's not you're not the first person to ask, Rad. It's come up quite a few times. We've thought about this, and it might happen. We have the software version tags in the environment file, so we do have that available. The downside is if someone wants to add some more functionality to the wrapper code itself, not leave the tool version unchanged, but change the process wrapper, then that process wrapper needs to have its own version as well. So then you're maintaining the software version, wrapper version, and the Docker version. And I'd kind of felt that this was very complicated. So my gut feeling is that in the end, we're going to have a single identifier, which is going to be the Git hash. That contains everything. It contains the wrapper, it contains the software, the container version, contains everything. Whether we add some kind of helper functionality, which finds a software version and converts that into a Git hash at a later date, that might be possible. But it's not going to be there straight away. For now, just use the Git hash. I'm hoping, to be honest, I would like to try and push everyone to use the latest version of all tools all the time. So really, I'm hoping that all this question of versioning is going to be a little bit mute, because you'll just run NF core modules update all, and it will just update all your modules to the latest version. And you check it works, and then everyone's happy. But of course, there will be some circumstances where you're forced to use older versions of software, and we need to make that possible.
Perfect, thank you, Phil. There is a similar question from Maxim. Could there be named inputs for processes, as there is also now, as also now named outputs exist? Maybe that's more a question for Evan or Paulo.
Yeah, I think it's for Paulo there.
Yeah, I fear that's for me. No, at least I think that will confuse even more. It's already quite start to be complicated. Maybe the syntax. I fear that will open the possibility to have too many options. I don't know. So, short question, I would say no. Long question, I don't know.
Maxim says, okay. Any more questions from our audience today? So Rad is commenting, I would argue against latest in favor of explicit versions and a way to have both version and hash similar to how you have tag and digest for Docker images.
Yeah, yeah, exactly. I think we're agreeing. The digest, I mean, a Docker tag resolves against a digest. At the end of the day, you always have a specific hash. And it will be the same for NF core modules. At the end of the day, you will always have a specific hash, and we might add kind of nice front functionality to make that easier to use in the future. But first, we're going to start with the hash and go from there.
I want to add a bit more about now optional and name it input parameter, because this is actually is related to the optional input. Now, because if you allow people to have a process in which the input are specified not with the position, but with the name, you can specify one. Imagine that you have a process with many inputs, and you specify just one with the name, and then you omit the other. So maybe if we have a good way to specify the default value for, and therefore the optional value for some inputs, we could have also a way to manage name parameter, because they are linked the two. So maybe in the future.
Would a map go anywhere towards solving that, Paulo?
Yeah, the map is doing that. The problem is that what is the value for something that you don't specify? Now we don't tell, no? So we should have also a way to specify a default value for a process input, but that become a bit weird because I'm not sure that they have much sense having default for a default value. You can have some specific cases, but that is more an optional input, in my opinion. Instead, you should specify a default value for each input. Otherwise, when you invoke the process, each time you have to specify the name and the actual value. The name and the actual value, that make very verbose the composition of the of the pipeline, I think.
Or could the default value be initialized as false or null or something? And unless
can you repeat, sorry?
Could the default value for any given input be null or false or something unless it's overwritten by being provided to the process?
Yeah, a default to 0, how to say? I don't know. I think that will open, so create more confusion, I fear.
A couple of people have chimed in on the chat here, and I was thinking the same thing. We could potentially try and steal how Python does this. I guess other languages as well, that if no name is given, you can just use the order of arguments, and if names are specified, then use those. But maybe this is getting a bit in depth for this forum. We can take this on Slack for a bit more.
Yeah, that could be an option, even though I'm not sure how much will improve the experience with the language. I don't know. It seems to implement this, then is a big work. So I prefer to focus on other stuff.
There's just hop on a question here about from Steve about how DSL2 works with params, and whether basically we will lose the ability to use params to kind of customize the way that script blocks run and things like this.
Yes, basically the model inherits the params from the calling model. So you can use params as in any other script. Implicitly, the model receives all the params that are in the invoking script. But you can still override if you need when you make the inclusion. There are some examples in the documentation.
So, yeah. And we'll be making use of this quite a bit in NF Core modules, as we saw in my talk earlier. I don't know if you remember, it said params.module name arguments. So we're using a regular params there to customize the script block already, just in a kind of standardized way. So yeah, params will continue to be a core feature of pipelines, even with DSL2.
All right, there seems not to be any more questions. So if there are no further questions, I'd like to thank everybody who contributed to this session. It was very interesting to have this discussion. And if people would like to contribute to us porting all our NF Core pipelines to DSL2, join us now, join us for the rest of the week. And yeah, this way you can make an impact on NF Core. So we can move on now with the summary of the developments in the NF Core hackathon. So we will present the progress that there has been in each of the hackathon projects. Maybe we'll make a 1-minute break and we'll be right back to you. All right, so I'm gonna show the presentations. Does somebody want to jump up and present what they've been working on their hackathon project?
Do you want to nominate one of the projects, and then someone from each project can maybe come forward to volunteer?
Yeah, we can start with the new pipeline development. So there were several people this time working on new pipelines. I'll share the screen to show the slides that they've prepared.
Do you need to enable everyone to unmute themselves so they can present? Maybe you've done that already.
I've taken care of that.
Perfect. So, Kamil, if you would like to present. All right, or I'll make just a brief introduction. So we had 4 projects for this hackathon, and this one was focusing on developing new pipelines. And those were the people, the group members that were involved in developing new pipelines for NF Core. And we have, first of all, the QTL map pipeline. Is there somebody here that was involved in the development of this pipeline that would like to give it a quick introduction for the rest? You can just unmute yourselves. All right, there doesn't seem to be anybody right now, but just a brief description. So the QTL map pipeline was proposed by Norlan Kerimov from the University of Tartu, and it's supposed to automatize quantitative trait logi mapping of so the connection between genotype and molecular phenotypic data. So that's quite an exciting pipeline to have alone. So we hope to see more developments this week of this one. We have also the RIFSIC pipeline.
Yeah, so I can mention that briefly. So this is basically a pipeline that I've been developing previously in SnakeMake, and for various reasons wanted to convert it into NF Core. Many of those reasons are all the bells and whistles that you guys already have implemented, and everything that is very nice about NF Core, that you have streamlined everything, and everything is already sort of working in a reproducible kind of manner. And so, yeah, I don't see much of the space, but basically this is a project, a collaboration with the Mats Nilsson's group in Stockholm University, and they have developed a new method for highly multiplexed RNA isolation-free RNA-seq. So I'm writing the pipeline, the bioinformatic part of this pipeline for them, and it's relatively simple in terms of gene expression, QC, and that sort of thing, except that it's got lots of steps of splitting and gathering samples, and needs some more advanced metadata in order to be able to run, because it also wants differential expression and some downstream analyses after the sort of standard stuff that the NF Core pipelines are already doing. And the weird thing about this, I guess, is that since the group hasn't really published this yet, this is still a private repo, and I'm not really allowed to share much of it. I was given permission for this hackathon to share if anybody wants to look at it and help out, but seeing as we're all very busy, I've been mostly sitting working on it by myself, and just trying to get it ready for NF Core inclusion once the group actually publishes their paper, which they are in the process of starting to write now. And this, yeah, I started it with DSL1 and has since started working with DSL2, not with any modules and stuff, but just the syntax. So quite keen on seeing what the modules can be doing, and enjoyed the talks so far today. So yeah.
Okay, perfect. Eric, thanks for this short summary of what the pipeline is doing. If there are any interested people also in contributing, then just get in contact with Eric. We have also the SimSecure pipeline. I think Kamil mentioned that he would be willing to present it himself.
Yes, indeed. Hello, everyone. My name is Kamil, and we have this time a team for a huge, well, quite a larger team from Artigen. Me, Pavel, Daniel, and Tomek. We are working on SimSecure pipeline, which main aim is to allow a end user who has set of annotated antibodies, for example, in a form of CSV file, to look up for antibodies in a reference set, which are, for example, matching annotations such as VGINs, canonical faults, or other annotations. Can you go to the next slide? And this reference may be, for example, one of the publicly available databases like OAS database, or our own antibody database, which we have. And the main problem which we commonly have to deal with is this particular sequence was already seen somewhere in our data, or any other similar antibodies, have we found them already or not? And this too it should be simple and should give this first overview over particular set of new sequences. And the SimSeeker is named from the Maltese word hawk, and it simulates the activity of hawk in finding what it seeks. Yeah, don't ask why this name was chosen. Can you go to the next one? So our progress, all four of us yesterday spent a huge amount of time on task definition and architecture design, and I think that we are ready for actual development. If you can switch to the next one. In the meantime, Daniel was writing a wrapper for Parasail tool. This tool we would like to use for actual sequence alignments. And if you can go to the next one. Also, in the meantime, when we are when we were brainstorming, Tomek also started our repository with NF-core template. I hope that one is in DSL2.
Yes, it is.
Oh, great. So we will be developing this pipeline in second version of Nextflow domain-specific language. And right now, Tomek is working on module which will validate our input data.
And the next one.
There is also one additional slide, I guess. Yeah, and currently our pipeline is residing in a private GitHub repository. But of course, if anyone is interested, we will be happy to share it. We don't have clear restrictions, but we also don't have any permissions to publish it yet. So we came with new idea for our common problems, and we just use this hackathon to make something new which will be helpful for us. Okay, thank you.
All right, perfect. Thank you, Kamil. Does somebody have some questions towards this pipeline? Please jump in yourselves. All right, so we can now continue with the GWAS pipeline. If there's somebody here that would like to introduce it.
I can introduce it. So it's a genome-wide association study pipeline, and I think this is quite new in the NF core world because all other pipelines are sort of sequencing focused, and this is at least a traditional has been starting from the genotype microarrays and then doing this genome-wide association study. So we have been in the Slack channel talking about this addition for some time, and I thought it would be nice to initiate it now during the hackathon. So we have been 3 people discussing and talking about it. Now this morning we dropped down to 2. What to say? The progress is that it is in the NF core repository, only with what the NF core tools create gives. So, but we will try to add some test data and get all the checks and so on running, and then create the basics for a basic GWAS. That's the ambition for the hackathon, at least. So, any questions on that?
Okay, sounds great. Hopefully now that the pipeline is already on the NF core repository, there will also be some further contributors. Otherwise,
exactly. There are, I think, 18 people in the GWAS channel, so that showed interest. So someone should show up.
Yes, it definitely raised some interest.
Yeah.
Okay. So I think that's it for the new pipelines team so far. We can continue with the existing pipeline.
I think there's the CageSec should be there after this. Yes.
Okay, perfect.
Sorry for that. Yes. So my goal for this hackathon, or one of the goals, is to write the documentation for CageSec, which is feature complete, at least from my side now. So if I have the documentation, I think it's good for a release. And if we go to the next slide, I finished a README, and then before writing the the usage documentation, or like it's already there, I just need to update it and fix some things there. I decided to go to an issue in the tools repository, or website repository, where there was the idea that we could use the parameters in the JSON schema to automate the usage part of the section. So now I switched over to this. So I'm now split in 2 projects.
All right, sounds great progress so far for this pipeline. It's been one that it has been already up for a while in the NF core repository, right?
Yes, it's, I think, at least a year.
Yeah, great. So let's see if we can push it for release this week. And if you can also find some further contributors here.
Yes, I would be very happy for new hands and eyes on it.
Yeah, perfect. So we have yet another pipeline, Pop Bomb Pipeline by Matthias Marquardt. So are you here available, Matthias, and willing to present it? Maybe he's not, but I can say a couple of words about this pipeline. So PopBomb is apparently an acronym for prediction of phenotype based on metagenome, and it's supposed to be a pipeline that includes some metagenomics analysis as well as some machine learning training, which is quite exciting, as we don't have yet an NF core pipeline that includes a machine learning process. So we'll see how this evolves. And I think now we are done with the new pipelines hackathon project. So we'll move forward with the existing pipelines hackathon project. Let me share the slides.
We have the deep variant pipeline. I think that uses machine learning.
Oh, right. That's true.
And to an earlier comment, we do have a few non-genomics pipelines as well. We have a few proteomics, and there's an image analysis pipeline as well. But yeah, they are mostly genomics so far.
Okay, I'm just finding the other slides. All right, so this is the next hackathon project team, which consisted in developing existing NF Core pipelines. And the group members are collected in this slide. They were working on many different pipelines, so maybe they can also jump in themselves and explain the projects that they were working in. So first of all, we have the NF Core Eager. Somebody willing to present this one? So the main developments for this pipeline was finishing remaining structural changes. I think there were also some problems on running it on AWS, which hopefully will be solved now. And finishing documentation and preparing basically the pipeline for the 2.2 release. There is also the NF Core SAREC pipeline. So Maxime, I'm sorry, but you cannot hide yourself. So you can present.
Okay, I'm here. Yes. So sorry, I was not on Zoom, so I just joined right now. So yes, so we've been working on SAREC, fixing issues and updating the pipeline, and we've just started working on DSL2, but I guess you will talk more about that on the next project. Can you change slide? So yes, so we created a SAREC team of core developer on Slack and on GitHub. We fixed a control freak issue. We fixed we fixed one issue for mutex 2. We added one option for mutex 2, and we switched from BWA to BWA main 2. So I'm hoping we should have a lot of improvement and a lot of speed up on the mapping steps. And that's all for now. So hoping we can be as productive tomorrow.
Perfect. Sounds like great developments for SAREC. Then there were some improvements of NF Core Mac as well. Is there somebody here willing to present?
Yes. I have a quick question for Maxime before we go ahead. Have the indices changed for BWMM2?
No. No, they do say that they provide the exact same result, just faster.
So you can still use the old indices. That's not changed.
No, that's what I did at the moment. I haven't changed anything.
Okay, cool.
But I'll do, of course, more tests just to be sure.
Okay, perfect. So we will move towards the NF Core Mac pipeline.
So yeah, I could say a few words to this. Daniel, Maxime, and me, we were working on the MEC pipeline. For those who don't know, it's a pipeline for assembly, binning, and annotation of metagenomes. And it was originally developed by Adrian Gollet and Daniel Straub. And yeah, I also started contributing a bit in the last weeks. And since we added some features such as host read removal and also some parameters to ensure the reproducibility of individual tools, we were working already towards a release, which we thought we could push this week as well. So there are a few remaining bugs and we still had to address. So Maxime, for example, fixed the memory conversion issue with Spartus. Daniel also worked on the compression of assembly files for the results output folder, which reduces the site significantly, and we changed some error handlings. And I'm still working on a problem with the Busco process, which is still work in progress. Yeah, that's it.
Okay, perfect. Thanks for the progress report, Sabrina. Let's see if by the end of the week we can release this 1.1.0. Okay, there's also another pipeline, NF Core DIA proteomics. Can somebody brief us on this one?
Yes, maybe I can say a few words. So I created this pipeline a couple of almost half a year ago, and just as an initial experiment. And now I thought I have the time to fix a lot of bugs, including template update, the container, which had to be updated. I didn't get very far yet. I had problems with the container, but at least that seems to be fixed for now. And I'm looking forward to get at least the basics running by the end of the week.
Okay, perfect, Leon. Thanks for the briefing. And that was it for the existing pipelines. So we can move on now to the next hackathon project. So we will continue with the improving NF Core framework tools, even though I think this hackathon team was not very popular, unfortunately.
It was an elite group.
Okay, let me share the slides. There they are.
Yeah, I won't talk for too long because we've been talking for a long time already. But yeah, this project is about everything NF Core, which is not a pipeline, basically. So it's the Python helper tools and the website and kind of a generic automation. So there's 3 of us, I think, if you go on the next slide. Yeah, there's me, Stephen, and Matthias. And we've been tackling a few different things. If you can just hop onto the next slide. So we kind of chatted to Stephen yesterday and talked about the kinds of things there are to be done on tools, and kind of going through some of the issues. And my suggestion was that he kind of starts off with some of the kind of more standalone issues, which were kind of not necessarily too ingrained and didn't need too much pre-existing knowledge. So he got started with working on NF Core list. I don't know if he's part of this group here. Steve, I don't know if you want to say anything about this.
Yeah, so yeah, like Phil said, I was just going through the issues list, and this one about the NF Core list showing archived workflows was one of the top ones that I saw. So it was pretty simple to implement. So yeah, now it does not show archived workflows by default, but you can use this new flag if you want to see them.
Thanks. Very simple is quite an important issue, actually, because these functions that power the NF core list subcommand are actually used by loads of the other parts of the helper tools. So the archive pipelines were trying to be synchronized, for example, which they shouldn't be, and other stuff. So this was a good one to get fixed. Yep, next is just sort of generic my work where I've been working on NF core tools. It's been a long time since we've had a release. Every time we say we'll try and make the next release sooner, and it's very difficult to do. So if you hit onto the next slide, I've been working through the kind of different issues which are pending for the next release of version 1.10 of NF core tools. Can you just hit next? And again. So basically, we use GitHub issue milestones to try and group things together so stuff doesn't get missed. I bumped a few of them over onto version 1.11 because I want to get this release out. Remaining stuff is, the big stuff is improving how NF core sync works. It's a fairly unknown command. Most of you won't ever need to really run it, but it's used by the GitHub automation. So when you have a new version of a template, you all get automatic pull requests on all the different NF core pipelines, proposing hopefully just the updates to the boilerplate code. And I completely rewrote this for the last release, and it worked fairly well, but there was like a few things where just after it'd run, I thought, oh, this stuff could be improved before next time. So I was going through that. And I also looked through the list of pipelines that failed last time and just vetted them and made sure that they were ready for the next synchronization. A few of you will have got messages from me where I went through trying to tidy things up. So I think we're in a really good place now for the next release. And also the NF core, so we have Python unit testing for most of the stuff in the NF core package and absolutely none for NF core sync. So I'm just writing a few unit tests for sync now. Next. All right, this is Matthias. Do you want to jump in, Matthias?
Yes, I can. So as teased already in the cage sec, I want to use the JSON schema parameters to generate at least parts of the usage documentation. So if you go to your pipeline and go to documentation, you will usually see the usage and then the output, which are currently rendered from the Markdown file. So everything has to be handwritten. And at least for the usage, we could, the plan is now to use at least the parameter definitions as one part of the documentation. And if you need more, you can still have the Markdown file attached to this page. So I got familiar with how the code looks like to generate the sites, and also like, yeah, sticking out all the parts which should be done. And yeah, I hope I will not follow this XKCD too much for this project, but we'll see.
Just for those who are not familiar with this, this is tying onto a huge new body of work for NF core, which we haven't mentioned at all yet, which is these JSON schema for pipelines. Don't worry too much if you don't know what we're talking about. I'm going to talk about this in quite a bit of depth on my talk on Thursday, where I talk about new things in the NF core tools package. But basically, yeah, it's a way to describe all of the parameters used in a pipeline in a kind of computationally friendly way, if you like, in a structured manner in the JSON schema file. And so we'll be able to have documentation auto-generated from this. So this is really starting to make use of this that Matthias is doing here. It's really good. I think that's it for our group.
Okay, perfect. So thanks for the developments, and we'll be at your talk on Thursday then to learn more about this. And the last group missing is the Nextflow DSL2 modules, which I know was a very active group. So I'm going to share the slides. And does somebody want to take the lead who was in this team? So the primary focus of the team was working on the DSL2 modules or porting pipelines to Nextflow DSL2. And members were Harshil, Gregor, Jose, and Frederike Hansen. And yeah, does somebody of you want to brief on the first slide?
Yep. So this has actually been quite a bit of fun, and from the previous talk, it's been a bit of a learning curve really the past couple of days. It's been intense, but I think we've needed to be put in this situation to actually make any progress with DSL2, and so now we're sort of in the fire pit, as it were. And so the idea that we took was that we would attempt to implement a pipeline end to end because it gives us a particular focus. And also it'd be able to help us identify limitations and fixes and other things when, you can get, I personally had to do things possibly in a messy way with DSL1, but with DSL2, all of that will be tidied up, things will be more modular. And so we thought we'd re-implement the chip-seek pipeline from DSL1 to 2, and because I'd just released a version of the chip-seek pipeline, it makes sense to now just port that pipeline directly to DSL2. And so the aim was there not only to start adding modules to NF Core modules, but also to try and implement them within the pipeline. So Gregor has done quite a bit of work on updating our main README on NF Core modules because it's become quite out of date, and we're sort of changing these requirements as we go along, essentially, so we're clear about things. Jose and Gregor also have been adding modules or attempting to add modules to NF Core modules with for things like bed tools and sand tools, and I've made a list. There's an issue on the chip-seek repo with a list of modules we'll need to implement in DSL2 to get this working. And so, yeah, it's just been a play as you go. And from some work that I'd done last week on the pipeline template, we've managed to strip out a lot of the boilerplate code that was in the template. So I've been getting my Groovy on for the past few days, trying to create a separate Groovy library that we can then use to import specific functions for the NF Core template within the main script, as opposed to having big chunks of code in it. And now it looks amazing. It's just incredibly satisfying deleting large chunks of code from the main script, because we've been planning to do that for ages. And I think Paolo done some work on that for the RNA-seq pipeline a while back, and Patrick done some more for the methyl-seq, and we've sort of needed to bring it all together, really. But that'll be quite nice, because then it will not only simplify the boilerplate code for the pipeline template, but we can then also use modules, which again is a condensed version of processes to even make things even that much more smaller. So yeah, so this slide is basically us talking lots at each other and trying to figure out how to go forward. Do you mind the next slide, please, Gisela? Thank you. Yeah, so Gregor's been working on this. I guess we've kind of been using this module as a test case to identify things we want to do and don't want to do with our modules. And we're sort of making steady progress on that. And it's sort of the typical software people use as an example, really. So it was a good starting point. And Gregor's working on this. Next slide, please, Gisela. So Rike is working on this, I believe, along with Maxime. Do you want to say something, Rike?
Yeah, I'm pretty new to modules. I mean, I've heard about them for a long time, but basically yesterday was my first exposure to them. So I'm real glad about the talks today. And this morning we discussed which tools we need. And luckily there's a lot of overlap with the chip-seek pipeline on needed tools. And currently I'm fighting with figuring out how to create my own module with BWMM2, since we just this morning also added it to the SARIC pipeline to the current version. And Gisela has also done a lot of work, actually, I think, on SARIC.
Yeah, I was mainly working on trying, because there is now a first version of the template for DSL2 in tools, thanks to Harshil, and I was contributing a tiny bit in the end. So I was trying to also see how SARIC would look like with based on the DSL2 template.
Yeah, you got multi-QC working, which I couldn't, so thank you.
Yeah, after a bit of fighting as well. Okay, so I think that's it for now. I'm gonna stop the live streaming right now.